Let us now look at two final interesting and very important concepts again in interest theory. So we're looking at nominal rates of interest and discounts, the relationships between them, and then we'll end with force of interest. What are nominal rates of interest? These are interest rates that are used for, or these are interest rates or discount rates that are used when interest is being paid more than once per measurement period, okay? So for effective interest rates or discount is being paid once per measurement period. But as with nominal rates of interest rates and discounts are being paid more frequently than once per measurement period, okay? All right. So for example, you may have an investment for a year. If interest be paid you just once in that year, then you are using effective rates of interest. But if the 1 year investment, you are being paid interest every quarter, every 3 months, you receive interest, every 3 months you receive interest, then the interest that yearly interest that is quoted to you is actually a nominal rate of interest, because there is actually an effective rate of interest for each quarter. Okay. So if whatever investment you are involved in, they will pay you on a quarterly basis, but they quote to you a yearly interest. That interest they have quoted to you is a nominal rate of interest. But if they quote to you a yearly interest and you be paid just once, then that interest they've quoted to you is the effective rate of interest. As we proceed, you understand it better. So nominal rate of interest, we use the notation I. We call this I upper M. Okay, it means it is payable, or the interest is payable M times per period. So if I upper M, the M here is 4, it means that interest is payable 4 times per period. Okay, and the effective rate of interest per period, not per the whole period, but per each M period, is I upper M over M. So for each, if for example we are using M is equal to 4, that we're looking at a quarterly payments in the course of a year, then we can get effective interest rates for each quarter. How do you find it? You take the nominal rates for the year, which is I upper M, and divide it by 4, and that gives you the effective interest rates for each quarter. Okay, so here is a relationship between the nominal rate and the effective rate of interest. We have 1 plus I equals 1 plus I upper M over M times M. You can do algebra here to make I stand alone or I upper M stand alone, based on what your question demands that you focus on. All right. So let me do an illustration to demonstrate the first relationship. So the relationship is telling us, or is saying that 1 plus I equals 1 plus I upper M over M all to the power M. Okay. So these are quarters. And the entire period is 1 year. Okay. So this is the first quarter, say January, February, March. And then April, May, June. Then the third one is July, August, September. Then the final one is October to December. So these are 4 quarters in a year. The effective rate of interest for the entire 1 year period is I. Okay. But if we are working in terms of nominal interest rates, I upper 4. Then we can find the effective interest rates for each period. How do you find it? You take your nominal rates, I upper 4, then you divide it by the number of quarters, which is 4. Okay, so for each quarter, the effective interest rate is I upper 4 over 4, I upper 4 over 4, I upper 4 over 4. So in fact, the nominal interest rates is just a name. It doesn't mean anything. It's just a notation. Okay. So sometimes when you go to a bank and you want to do an investment with them, you may ask, not a T-bill, the bank's own investment or fixed interest they do. They'll quote to you that the interest is 20%, and you are happy because you think that, and we'll pay you monthly. They'll tell you the interest is 20% and we'll pay you monthly. And you are happy because you think that, hey, every month I'll get 20% on my investment, but that is not the case. What they have given you, that 20% is your I upper 12, because the 12, they'll pay you monthly, so they pay you per month. So it's a 12 period, it's a 12 period in the whole entire period. I upper 12 is 20%. But in actual fact, every month, what you earn is I upper 12 over 12, which is 20% over 12. And that is 0.2 divided by 12 is 1.67%. So you actually be earning 1.67% each month on your investments, not 20%. The 20% is the nominal interest rates for the entire year. But once they tell you that they're going to pay you on a monthly basis, it means this is actually what you're going to be earning, because they'll divide that nominal interest rate by the number of divisions within the period, which is 12, because they are paying you monthly. So please take notes, okay? This is how nominal interest rate works and how you can find the effective rates per the period within the entire period. All right. How about nominal rates of discounts? It works very similarly to the nominal rate of interest, okay? So here you have D upper M. I didn't write it well. It's supposed to be written this way. D upper M. It means that the interest is being paid, the discount is being paid M times per the period we are considering. So what's the relationship between the nominal rate and the effective rate of discount? Our effective rate of discount is 1 minus D, and our nominal rate of discount is 1 minus D upper M over M, all raised to the power M. Okay, so you can use your algebra to make D standalone or D upper M standalone. Here is D upper M. Pardon me, I'll correct it before I give the notes to you. Okay, this is supposed to be D upper M, not I upper M. Okay. So here we have it. We can also find a relationship between nominal rates of interest and nominal rates of discount. These two nominal rates, okay? So here's the relationship. 1 plus I upper M over M, all raised to the power M, is equal to 1 minus D upper M all over P, all raised to the power minus P, okay? All raised to the power minus P. An example here for us. Find the accumulated value of 500 cedis invested for 5 years at 8% per annum, convertible quarterly. Look at the way the question is. Find the accumulated value of 500 Ghana cedis invested for 5 years at 8% per annum, convertible quarterly. It means they've quoted a yearly rate for you, which is 8%, but it's being paid to you quarterly. So the 8% is a nominal interest rate. You have to find the quarterly effective rate. That's dividing 0.08 by 4. All right. And then you will use it to work. Okay. So let's try it. The solution is given here, but I want to work it together with you. So in the question, we are given the principal is 500. The nominal rate of interest is 8%. Time is 5 years, okay? So it's a 5-year period. I upper 4, because we are converting it quarterly, is 0.08. So what is our accumulated value at the end of the 5 years? We know that for nominal rate of interest, you have your principal times 1 plus I upper M over M, or raised to the power M. Okay. Here, M is equal to 4. So our accumulated value will be 500 times 1 plus I upper M is 0.08. The period is M, which is 4 times 4. But remember, there are 5 years involved, so you must multiply this by 5. Okay. So there are 5 such years of 4 quarterly payments. So if you input all this in your calculator, you should get 500 times 1.02 to the power 20, and then you can write your final answer down. Okay. So note that this situation is equivalent to one in which 500 is invested at a rate of interest. If you look at this summary here, there's this simplification. You can see that it's more or less like we are investing 500 for 20 years at a rate of 2%. Okay. So that's what, because there are 20 periods involved. If there are 5 years, with each of them having 4 quarters, then we have 20 periods involved. All right. So there are other examples for us we can try. The solution is given already here. This is an example where the discount is used instead of interest. Okay. And this example is talking about a relationship between the interest and the discount. So you can practice these for better understanding of the formulas that you have been given. Okay. Now, finally, let's look at force of interest. Force of interest is the measure of interest at individual moments of time. So with force of interest, you want to measure the interest at now. What is the interest rate now? Okay, at an exact time t. All right. So the force of interest at time t, which is we denote it by delta t, delta subscript t, is defined as the first derivative of your accumulation function over, no, this amount function, the first derivative of your amount function divided by the amount function, which is also equal to the first derivative of your accumulation function divided by your accumulation function. Now, delta T is a measure of intensity of interest. That is, what is the interest rate at exact time T? And delta T expresses this measurement as a rate of interest, or as a rate of whatever per measurement period. Okay, so it considers the interest rate per measurement period. Now we have two types of force of interest. We have the varying force of interest and then the constant force of interest. So on the varying force of interest, if you want to know what your accumulation function is, AT is equal to what we have here, the exponent of the integral of delta T from 0 to T, all right? And then we also have the constant force of interest, and the accumulation function is given as e to the power delta T, which is also equal to the effective rate of interest accumulation function. That's 1 plus I to the power T, okay? You can do algebra on this and know that delta is equal to ln 1 plus I, okay? So force of interest is quite easy to work with, but if you have simple delta functions, you can also work with varying force of interest. So let's see how the force of interest can be used to calculate our accumulated values and our present values. Here are two examples. Find the accumulated value of 1,000 invested for 10 years if the force of interest is 5%. Find the accumulated value of 1,000 invested for 10 years if the force of interest is 10%. Let's illustrate it. So the amount invested is P is equal to 1,000. The time involved is 10 years. And the force of interest, delta, is 0.05. Which you can see that once you have delta being a constant like this, it means delta is a constant. We are dealing with constant force of interest, okay? There's no T attached to the interest given. It's a constant. At any point in time, our force of interest is 0.05. How do you find accumulated value? You know that you need to multiply your principal by your accumulation function. And then the force of interest, AT, is equal to, and for constant force of interest is delta T. Okay, so we come here, finding our accumulated value, we have P, which is 1,000 times 80. So e to the power, delta is 0.05, then T is 10. So when you fix this in your calculators, you get whatever value you get, you write it down. Okay. So number 2 is also another example concerning force of interest. You can try that, and we will talk about this when we meet in class, okay? So this is the end of our lecture on interest theory. I hope it's been a good refresher for you, and for those who have studied it before, and for those who haven't studied it before, I hope you have learned something on interest theory. I will encourage you to watch this video as often as you can to get every detail that you need. Please do also write down your questions as you watch these videos, and we'll meet in class next week. And when we do, you give me all your questions and we clarify them. We also do practice questions in class. All right, all the best in your studies.